Okay, let's get this on the go. Welcome to the Royal Astronomical Society St. John's Centre. I'm Gary Diamond. I'm sorry to hear that you're stuck in a house for the next 14 days. Looks like we're going to be doing these meetings by way of Zoom. I was talking to across the nation there, and I seems like other centers are getting more members showing up, and I thought we've had some really great talks this year on Zoom because of Zoom, but we don't seem to be getting too many members taking part. I don't know why. I figured people from outside the city would love this. I don't know if we're advertising it right or not. Anyway, I want to welcome you all, and this is a members night because I like to know what members are doing. Some members do a lot. I run into them every now and then on walks, and they tell me they're doing this, but they don't want to tell anybody else. But some members are willing to talk. And I'm going to start the night off with a talk on, I guess it's called Citizen Science Now, CamPro. There are a lot of things going on. The one that I'd like to talk about is very simple. It's since the comet Shoemaker-Levy hit Jupiter, amateurs are now finding meteors hitting Jupiter. It's a quick, easy thing to do. Matter of fact, the program now is so easy that when AutoStacker 4 comes out this year, the program for finding that will be included into the system. So if you don't mind, I'm going to share my thing, and I'm going to let Marc Delcroix, I think.
Hello, my name is Marc Delcroix. I am director of the Planet section of the French Astronomical Society, and I will talk to you about detecting impacts on Jupiter through amateur videos. Since 2012, software was developed in order to discover flashes on amateurs videos, flashes which are provoked by impactors hitting the atmosphere of Jupiter. The software has evolved, and a project was generated out of that with an additional aim, which is to estimate the frequency of the impacts on these videos, just by collecting all of the results of the analysis that amateurs do on their videos and processing that in order to estimate this frequency. Now, technically, how the software works in order to attempt to detect these flashes, there are two ways. The first way is by an algorithmic way, by processing differential photometry on successive frames of the videos in order to detect when there is an increase of brightness on Jupiter zone, increase of brightness which can be provoked by an impact. Another way is to generate a single detection image out of each video. The process, how it works, is described there. What is the current status of the project? You can see that we gathered a lot of data going back even to past videos in 2003. You can also see the evolution here of a number of observations. Number of observations are the blue bars, and out of observations, if you accumulate all of the duration of the videos, this is the orange line that you see there. Each year is the apparition year of Jupiter. You see that for last apparition in 2019 we got a record number of observations, and that was provoked thanks to a very exciting event, which was Ethan Chappell's discovery of the sixth flash. He did this discovery in August 2018, and that was thanks to detect, meaning he did not observe live the flash, and without the software he would have missed it. For this year 2020, for this operation, participation might not look so good, but actually it's quite good because at the time of EPSC 2020, September this year, we are not done with the operation. I estimate that we still have 3 or 4 months of Jupiter observation that we will get from amateurs. So it means that my expectation is really to have something, participation at the end and a number of observations at the same level or even more than 2019, which is quite good. More data means more chance to detect flashes. It also means better estimation of impact frequency. From all of the data that we collect through the project, there is some specific data which is quite interesting. It comes from the Peak Dumidi Professional Observatory. Here, professional and advanced amateurs use the dedicated 1 meter telescope for solar system objects observation. And since 2012, all of the data which was acquired there was processed through DETECT in order to participate to the project. Here you see a magnificent image which was acquired with this telescope. This is clearly a demonstration of the excellent seeing that we can have at Peak Dumidi, and also the benefit of using a big telescope, 1 meter diameter size. So in the long run, we are clearly expecting to get positive detection and to have the possibility also to get some faint positive detections coming from maybe smaller impactors, because of course such condition, such a telescope gets more light and more more resolution than a regular amateur observation. All of the data that is analyzed is updated daily on the webpage of the project that you see here in the background of this slide. The URL is there to get to the project. The result that we have currently is quite important. I mean, we have analyzed more than 144,000 of videos. It's a huge amount of data, and the duration of these videos simulated is equivalent to 156 days of Jupiter observation. It's a lot, thanks to these 106 observers. The impact frequency that we could derive for Jupiter out of this data is around 14 impacts per year. Now, 14 impacts per year, is this coherent with other works, with other methods for estimating impacts on Jupiter? Answer is clearly yes. Ricardo Ueso and colleagues published in Astronomy and Astrophysics in 2018 a work where the result of impact frequency estimation is in blue there, and you see in this graph this orange part is the result coming just from DETECT. So it's clearly in the blue area, it's coherent, even if it's rather on the lower side of the estimation from the work. Additionally, in red and orange you have estimation of impact frequencies coming from dynamics modeling of comets. It looks coherent. This year also I developed a new version of DETECT, which is really a major one. The GUI has been fully redesigned with the aim of being simpler, more informative and attracting new amateur astronomer users. There is also, of course, a quick user guide which has been updated in order to use this new version, and which also helps the amateur observer to analyze the detection image which are generated and also to send the results. Additionally, performance has been increased by implementing the possibility to process videos in parallel, taking advantage of multi-core processors that are quite common nowadays. On my configuration, I could improve the performance of the software by 6, so it's really bringing something visible. The last main change was fully 16-bit support in implementation, so for fits and the classical image file format, and also for all of the videos formats that amateur astronomers are using. This project would not be possible without the observers that are dedicating their time to sometimes really doing only impact detection on their observation, sometimes additional work on their regular imaging, and I really want to thank all of them. Here you see pictures of only 1/4 of them, so the community is quite large, and it has been really a pleasure for me to work all these years with these persons analyzing their videos and contributing to this really important professional amateur collaboration project. I think it's really, that project is really a showcase of what amateurs can bring to the professional community. Of course, there are a lot of observers, but there is room for anyone else who wants to join, so I strongly advise you to do so. As a conclusion, I think we are really in a new phase of the project, with participation growing really fast over the last 2 years, so it's quite exciting. The scientific results that we get are coherent with our works, so if you are already using the software to analyze your videos, I really ask you to update to the latest version of the software. It will bring benefits to you, but it will also help me being more efficient in analyzing your results. And if you are not participating to the project, and if you are an amateur regularly observing Jupiter, do not hesitate to participate. It's easy, and the only thing that you risk is to be the 7th impact flash discoverer. Please really do not hesitate to contact me directly if I can be of help, and if I can have help you to kickstart participating to a project. Thank you for your participation, and I wish you a good day. Bye.
This is a really good project, quite easy to do. I started in 2016. He's analyzed all my Jupiter and Saturn from that I had back to 2003. I had 2 positive negatives. In other words, I had 2 that said there was something happening, but in actual fact, it was wrong, so it helped improve his program. It's an interesting program, barrel of fun. Another one that's interesting is, of course, if you have a meteor camera, and I just want to bring that up because if you're interested in you have an all-sky camera, there's a conference this weekend coming up. Give me an email if you're interested in attending. It's free, and it may open your eyes. So what else is on the next, Randy? Any questions?
There's some things on the chat there. Is someone monitoring the chat function? Anything to bring up?
I usually get Chris to do that. But I forgot to tell him at the beginning.
No, I've been looking and writing and answering. Let's see. Mike says one looks like Gary. Well, Svetlana mentioned she has a seminar tomorrow. She provided a link. You can open your chat window to see it. Mentioned Starlink. I commented, yeah, Starlink. I mentioned that Mike mentioned the talk by Samantha LCAP. Have a look at that. Then Mike said one looks a lot like Gary. Phil says, "Det you, Gary."
Yes, it is.
Yeah, I'm next. I guess I'll just do a quick. I don't know if people realize that we submit an annual report, and that gets included in the Society's AGM report in June. I don't know that a lot of people read it, so I'll just go through what I wrote for the annual report. This is for the, I call it the year in review 2020, covering the period October 2019 to September 2020. Next, I have Nikolai with a collection of Soviet space pins.
All righty.
There he is.
All right. So I'm going to show you the physical pins, as well as I'm going to share my screen where I took higher resolution of pictures of those pins so that you can actually see in better detail what's on them. So here first I will show you the pins themselves. So right here are, the physical pins, which hopefully one day I'll be able to bring to our meetings and people will be able to touch them without fear of contagion. But for now, we'll have to resort to this. So let me share my screen. All right, can you see this?
Mm-hmm.
Okay. So I guess a little bit of background first on these pins. As many of you know, I am originally from Bulgaria, and that has enabled me to collect those pins fairly easily because they are still, fairly common in like antique shops and things like that, or like just people selling them on the street. So I kind of made a mission to collect space-related pins at, as soon as I saw them, maybe like 10 years ago. So they're fairly cheap when you see them. They're about, I don't know, the equivalent of $5 to $10 each, considering that some of them are, 50 to 60 years old. And they're basically representations of achievements in space exploration, astronomy, related sciences by the Eastern Bloc and specifically by the Soviet Union. So because Bulgaria was a communist state until 1990, it was in that sphere of influence, and those pins were very much circulating around the country, and so a lot of people have them still. So it is easier to find them there and cheaper than it would be, elsewhere. So I'll show you. I have 9 of them here. I will show them to you and kind of give you a brief background on what they're about. So this is the first one. Can you see it okay? Yeah, okay.
Yes, yep.
All right, so here it says the 4th of October, 1957, and it shows the Earth with this orbit around it and the satellite orbiting it. And here it says, first in the world, Soviet artificial satellite of Earth. So this is, of course, Sputnik. And this pin commemorates that. That was the date of it. And this is actually a postage stamp made into a pin, because over here it says 40, the equivalent of cents, I guess, 40 cents. So that's how much this postage stamp was. And it's engraved into this metal casing with, of course, the star, the symbol of the Soviet Union and communism. So that's the first one. This is the second one. It says 12th to the 14th of September 1959. And this thing, which reads in English as CCCP, is in Russian SSSR, which is in English USSR. So this is basically, the Soviet Union as name. And it shows the moon, and as well as this rocket and lander. And of course, this is the mission Luna 2, which has a lot of firsts. It's the first landing in a foreign body. It's the first lander on the moon. First, exploration of an extra, or non-Earth body. So all that happened, in 1959 and was commemorated in this pin. Number 3, this is one that commemorates the first human flight in history. And here it says, Slava покорителям космоса, which means glory to the conquerors of the cosmos. Very kind of propaganda-like language. And here are listed the 4 missions that accomplished that. And Vostok 1, of course, is the one that carried Yuri Gagarin into space. And he is, of course, the first human in space. And here it says, I guess, glory to the SSSR or something like that. So yeah, this is what this one is about, and it represents this human kind of jumping out of Earth and exploring, beyond Earth, essentially. Okay, next one is one of Yuri Gagarin himself. So this is his portrait, and it is it's engraved into the pin. So this is, a very small pin. So this is, a pretty zoomed in version of it. But up here is the star, of course, and here it says USSR, and here it says Soviet hero of the cosmos. So that's that. This is kind of a generic pin. It's not about anything specific. It just says Cosmos and USSR, and it shows this rocket in a star coming out of Earth, basically. So everything needs to have a star. That's how communism worked. This one is my favorite. A, because it just looks very cool colors. And B, because it's about planetary exploration. And, my interest in astronomy has always been in the solar system planets. So this one commemorates the 2 Venus landers. So Venera 9 and Venera 10. Those are, of course, the 2 missions or the first landers on another planet, and the first landers on Venus. Of course, those were major achievements considering how hostile Venus is. And they managed to land on Venus and transmit for a whole hour before being, corroded and crushed and killed by the hostility of that planet. And I like that Venus here is represented as kind of a flat surface with these rocks and stones on it. And that's essentially an accurate representation, because what those landers saw was a fairly flat surface, but lots of stones around. So this is kind of pictured here. And of course, the contact with Earth, which, fun fact, if you look at the Earth here, you're probably used to seeing a picture of Earth centered on the Americas. This one is, of course, centered on Eurasia, which is where the Soviet Union was located. So there's that fun fact for you. But this one's definitely my favorite of all. This one is about the Salyut 6 and the Soyuz 27 and 28 missions. Salyut 6 was kind of an early prototype of the International Space Station. It was basically a space station where humans visited, and however, only people from the Warsaw Pact could visit. And those two missions are the two missions that exchanged, sent people there and brought them back. And the reason why you see two flags, the one in the back being the Soviet Union and this one being Czechoslovakia, is that on the Soyuz 28 mission, it carried a man from Czechoslovakia, and he was the first human in space who was not either from the Soviet Union or from the United States. So that's commemorated here, and that was in 1978. Actually, the Soviet Union had, it was behind all this space exploration, but it was also working with its allies in the Eastern Bloc and kind of pumping a lot of money to help them also explore space and whatnot. So this is an example of that. And this is the last one. Those two are basically kind of similar to the previous one, where they represent cooperation between the Soviet Union and allied countries. So this one here to the left says USSR and Cuba, and those are the two flags. And the one to the right is USSR and Bulgaria. And Intercosmos is the Soviet program that actually was specifically targeted at helping the allies of the Soviet Union that were not part of the Soviet Union, because Bulgaria was, is an ally of the Soviet Union, but it was not part of it. Helping those allies get people in space. And it was through this program that all of these other countries, like Cuba and Bulgaria, Vietnam, just random countries that were, communist countries at the time, that's how those countries actually managed to have a person in space. And Bulgaria has had two of those through basically thanks to that program. This is what those spins commemorate. And also, I guess, fun fact, the only flag here that has not changed to this day is Cuba, because Cuba is still a communist state. Bulgaria is a democracy, and Russia is kind of a democracy, I guess. So, I mean, it pretends to be one. But yeah, that's it. That's all I have, and hopefully, I'm hoping to, whenever I go back to Bulgaria, usually once a year or so, I try to search for those and to get new ones if possible, kind of to expand my collection, which it's pretty cool, I find. So that's it.
Thanks, Nikolai. The chat window, and I'm waiting until after people speak before I go through the chat. I mean, I can interrupt if people want me to, but so Meetings RASC asks, how long have you been collecting?
About maybe 5 years, give or take. Okay. I don't actively collect them. It's mostly like if I go back and if I see them somewhere, or if I think about it, I go and get them. So it's not like, an active collection, but there are, thousands of, Soviet era, space era pins. This is just just a few of the more common ones. So
Phil asks at one point, that's the logo of the Russian Space Agency, isn't it? The rocket and the star? And then he says, cool.
yeah, so Russia basically, you know, with the fall of the Soviet Union, Russia had all this infrastructure and capability that basically carried over. So essentially everything is, well, not everything, but a lot of it was preserved. And a lot of what happens with Roscosmos today is, you know, founded on what was built during the Soviet Union. So yeah.
Yeah, I should modify my statement or question there and then say that I don't think it exactly is, but the logo looks something similar to that for Roscosmos.
Which one is it?
It's the one with the rocket and the star, the generic one that you showed.
Oh, this one here?
That one.
Yeah, that one. It's not, that isn't actually the logo. I mean, without the globe, that isn't the logo, but the logo for Roscosmos is something similar to that.
Yeah.
But it's okay. That was my first reaction to that, and then I thought about it later and went, "Oh, okay, yeah, not quite, but it is something similar." It's
Yeah.
So Gary Snow says, as good as any mineral collection I've seen. Marcellus asks you to make a list for your next trip and see who wants what pin.
And see what? Sorry?
Marcellus wants you to figure out who wants pins. Wants you to go
okay.
pin shopping for them.
Oh, I can definitely do that. That's no problem.
Nikolai, I had a friend from Czechoslovakia who was a science director in an observatory, and he actually got to visit the Baikonur Space Center. So before he left.
Yeah, yeah. A lot of these missions are happened at Baikonur, which is, I guess, is in Kazakhstan. Yeah. Which is no longer part of the same country, but Russia kind of owns that land or has some kind of a contract with Kazakhstan or something like that.
And I think just the other day was the anniversary of a total solar eclipse that went through your hometown, I think, in the 60s. It was clouded out, but
I don't know.
69 maybe? I'm not sure. It popped up in my Facebook feed.
The one that I saw was in 99. It was in August 11, 99.
No, it was before that.
That was a total eclipse that
Yeah.
brushed northern Bulgaria. It was the first one that I saw.
Yeah. This was before you were born, I suspect.
Yeah, a lot of these things happened before I was born.
Okay, if you got no more chat there, Chris, we'll go on to Mike.
Can you unshare there, Nikolai?
Yeah.
Please.
Yep, I think that's it.
Next is Mike Morrow, and he's got astronomy stamps.
Okay.
Yes, you can.
Yeah, so I've been collecting stamps for 55 years, but I only started on the astronomy stamps a few years ago, and I'm up to about 160 now, but I've just picked out a few sets that I thought might be interesting. And there are some that are sort of historical astronomers and things like that, but there are also some for different events. And that's kind of the sets that I've picked out tonight, a few of those. So there were one of the events getting to be 35 years ago now or more was Halley's Comet, and many countries had sets. And these ones are from Nicaragua, and they're nice. They've got a picture of the orbit of Halley's Comet, and then different instruments, the Hale Mount Palomar telescope, the Herschel telescope, and some sort of schematics of Newtonian, Cassegrain, and Ritchie, and the Galileo telescope. So that one's kind of nice. So here's one from Bulgaria. This is another Halley's Comet. So maybe Nikolai can jump in and say what some of these satellites are around the border, and the planets I can more or less pick out, because from collecting stamps you start to be able to sort of sound out what things are. So Mars I can see, Jupiter, sort of Saturn. Uranus is a bit of a mystery to me, how that ends up being Uranus.
That's
and
Uran.
that must be Neptune. So, are you there, Nikolai?
Yes, I am. Can you hear me?
Yep.
Yeah, so up left is the spacecraft called Planeta 1. I'm not familiar with it, to be honest. I'm not sure what it did. The one in the upper right is Vega. That one is a bit more well known. That one was a Soviet cooperation with other countries, including Bulgaria, and it visited Halley's Comet. And interesting thing about the naming of it, Vega, other than it meaning the star Vega, it also is an interesting combination of missions. So the V part is from Venera, which means Venus, and the reason for that is that spacecraft basically went to Venus, but it also kind of took pictures of Halley's Comet. And the Ga part is Russian for Gali, which is Halley or Halley's Comet. And so it combines the two missions in it, the Venus part and the Halley's Comet part in it. And then in the bottom left, there's Giotto, which I want to say is, it's an European space.
Yeah, I think that was European Space Agency.
Yeah, Italian.
That was a comet sample return one, wasn't it?
No, it wasn't a sample return, but it was. It visited Halley.
Okay.
Took pictures.
Yeah, I read a book, Giotto to the Stars.
Yeah.
Mm-hmm. And the one in the bottom right is Pioneer, which is,
Okay.
it's interesting that it's there because that's an American mission, and this stamp is from 1986. So I find it interesting that, or is this stamp from 1986, or was that just when the comet was?
Yeah, I think so.
Okay, well, it's just interesting that an American thing is on this, considering the political climate. And then in the bottom center is the Rajin Observatory in Bulgaria, which is kind of, it's the main astronomical research observatory in Bulgaria. I visited it. It's pretty cool. And then, yeah, everything else you kind of said. The planets, the orbit of Halley's Comet, and it's also 25 stotinki. That's the cost of this stamp, which is the equivalent of, I don't know, maybe 18 Canadian cents.
And what does the NOWA, I see that on every Bulgarian stamp.
Where's that?
After the CT. So in yellow?
Oh, that's PO. That's posta, which means.
Oh, okay.
Yeah, postage.
And what is the sort of script on either side?
It says People's Republic of Bulgaria, which.
No, I meant on the sort of rim of the whole souvenir sheet. There's.
Yes. This says Haleva Kometa, which is.
Oh, okay.
And then at the top is Edmund Halley.
Okay.
Mm-hmm.
Very good. Well, thanks. I learned something from that. Well, so how do you get Uranus out of that 4 letters there?
That's Uran, so it's basically urine.
Oh, okay.
That's it. But everything else it's pretty similar. It's Jupiter for Jupiter.
Yeah.
Yeah, Neptune, Saturn. Yeah.
Cool. Thank you very much.
No problem.
So here's a So there was 1992 seemed to be a special year. So different countries had sets of stamps. So I just have a page out of my stock book from that year. So there's a set of Australian stamps with the Helix Nebula, the Pleiades, and a Spiral Galaxy NGC 2997. And Great Britain had something with some planetary nebulae and some galaxies. And Portugal had a whole set of stamps, which are mostly different kinds of telescopes. There's also an astrolabe and a quadrant here. And so that's what I had from 1992. There was in 2007, Ireland had stamps, and they had a little booklet that came with it. So the booklet actually has 3 pages that look exactly like this with these 4 stamps. So even though the booklet is called The Planets, the stamps really only show the Earth and the 4 gas giants. And if you look very closely in here, in sort of gold ink or brownish ink, they show the relative sizes of the Earth and the different planets. Saturn, Uranus, Neptune, and Jupiter. And the booklet's about a dozen pages. So it's actually a very nice little booklet, but they just have the same sheet of stamps 3 times through the booklet. So I don't know what happened to the other planets. So 2009 was an international year of astronomy, and there are a lot of countries, especially in Europe, but I think Canada did as well, that had special stamps. And Portugal had 3 souvenir sheets like this, one for Portugal, and then one for Madeira and one for the Azores. And the stamps were in them were a little bit different. For the sort of format of the souvenir sheet was the same. And this one is a telescope. It says a telescope built by a student of the astronomy degree, University of Madeira. And then this is M51. So those were very, very nice looking souvenir sheets. Here's another one for Nikolai. So this is Bulgaria's stamp from 2009. I made a mistake there. That should say M31. So this is M31. So ignore the M51 there. That's from the previous page. And something I'm not familiar with, another spiral galaxy. And do you see anything else in there, Nikolai? I guess that one's pretty simple. I think I can see astronomy or.
Yeah, astronomy, Bulgaria, Europa, which I don't know what that Europa stands for. I don't think that's for the Jovian satellite.
No, that's basically, there was a whole, I think it's like the European community by 2009. Is Bulgaria part of that now? But
yeah,
all of the countries in the European community had astronomy stamps, different themes, and they all said Europa on them.
Gotcha. Yeah, no, they're pretty generic, other than the postage cost, which you multiply by, I don't know, 0.7 or something to get Canadian dollars. So in case you're interested, but that's pretty much it. I don't really see anything else on them.
Okay, so the next one here, these are some stamps from Germany in 2011, and I'm not sure what the event was for this, but there's one of the Horsehead Nebula, one of the Pleiades, and then a pair of stamps together showing the planets. Not necessarily to scale. No, not really. And that was a nice set. So this one was very, very nice. This is the from Portugal in 2012, the for the transit of Venus. So it's quite a large souvenir sheet. You can see Venus silhouetted on the sun up here, and it's showing where Venus is in 2012 and 2004. So I guess the previous transit must have been 2004. I'm a little puzzled. Are the orbits that much inclined to each other? Anybody know about that?
No, that's
What's going on here then? Do you know?
it's exaggerated because only a certain inclination, but they're not. They're only 1 or 2 degrees apart.
Okay, so they just exaggerated it.
Yeah.
Okay. Anyways, I thought that's a nice, pretty souvenir stamp. This one is from India in 2018. It's just showing all the planets. So it's this is basically almost the size of an 8.5 by 11 sheet, just a little bit smaller. And they've put all the planets, I think. Yep, looks like not to scale. And some other stuff, and I guess some asteroids there. And then the last one I've got is was actually a gift from Randy. These are stamps from Taiwan last year, and they're sort of solar system events. So an annular eclipse, a comet, a total solar eclipse, and this represents a lunar eclipse. And so those are just some of the sets of stamps that I've got. I don't have all the astronomy stamps yet, but I'm getting the ones from the countries that have the most interesting stamps. So I'll stop sharing that now, and sorry about the issues at the beginning.
So stamp collecting is called philately?
Yeah, philately or something like that.
Philately, so I'm philately edified, informed.
Good.
Thank you.
You're welcome.
Okay.
Thank you.
Svetlana, you wanted to mention the astronomy courses at Grenfell?
Sure, thank you. Well, those are really, really cool collections, and I guess I'm collecting online courses now. So let me share my screen really quickly. Here we are. Okay, can you see that?
Yep.
Excellent.
Yes.
Excellent, thank you. Well, I'm not traveling, I'm not going anywhere. My most upsetting day last year was December 14th because I was supposed to be in Chile, and well, I was in Corner Brook. So you can imagine, total solar eclipse, and I missed it. Well, I guess I'm entertaining myself now by developing online courses, and I have 3 now. One of them is Foundation of Astronomy. It's called Physics 2150, which is night sky, telescopes, space science, formation of evolution of our solar system, and just planetary system, planets. So that's number 1. Then if people are interested, the next one is 2151, which is more about astrophysics, which is classification of stars, stellar evolution, stellar nucleosynthesis, supernova explosions, Big Bang, dark matter, cosmology, all that jazz. That course is mathematically a little bit more involved, so the prerequisite is 6 credit hours of Mathematica in the first year level. The 2150 doesn't have any prerequisites. And the next one, which is in progress now, well, this is not exactly astronomy related, but that's another passion of mine, and also my own research field, which is subatomic physics, nuclear and particle physics. But there is also a bit of astrophysics in that too, because it's cosmic rays and again, formation of elements in the stars and so on. So what they look like is every week there is some material to be covered. So that's 2151, as you see, charting the heavens, Copernican revolution, telescopes, and there's a home assignment every week. This is 2151. Again, some material home assignment every week. It's more about stars and galaxies and evolution of the universe. And again, it is completely online. I guess right now is a perfect time to teach online courses because more people are getting online and more people are getting used to the idea of learning online, and that's open to everyone. So everyone is, it's not just physics majors or minors. It is open for everyone. I think a course like that is just a perfect gateway into astronomy. So astronomy is fascinating, and that's a great way to start. And of course, because there is no regular interaction with the instructor, it has to be very, very interactive. And it is interactive online. So anyone, anywhere can take it at their own time. There's no scheduled classes. You just do the models online and anyone can do it. Students from Labrador, anywhere. I'm really striving to make it accessible, especially to the remote and rural regions of Newfoundland. I want to make it accessible to anyone. And I was actually invited to give a seminar about that. That's tomorrow at 1:30, and here is a link. I have posted that link in the chat in case anyone is interested. So that's tomorrow at 1:30. That's about 45, 50-minute talk about designing online courses specifically. So if there are any questions, I would be happy to answer.
Thank you. Chris, was there anything in the chat?
Just a quick exchange between Gary Snow and Mike about stamps. Gary had some 2009 Canadian stamps. He's going to send pictures to Mike, thank them. That's basically it. Svetlana, I recognized a couple of your illustrations from the Pearson text that I think is probably related to the one I used when I taught 2151 a number of times. So good luck with it. I'm sure you'll have fun.
Thank you.
Thanks, Svetlana. This is Phil here. I remember actually taking those courses a long time ago when I was a student at Memorial, eons ago now, over 20 years ago. And I remember the in-class experience was fun for that. The courses you're designing are meant to be interactive. There's no presentation by yourself, I take it, in the courses that you're designing. They're meant to be totally interactive online with what is offered.
Yeah, they are very interactive. There are simulated labs and so on. And of course, there is YouTube. So I'm constantly looking for good short videos and I embed them in the course.
Right on. Yeah, I think there was a chat question about the cost of the course. I was going to echo that. These are regular courses at Memorial, right?
Those are regular courses. So the cost is, Mike, maybe you remember. They're not expensive, but I don't have exact number at the top of my head.
I don't know exactly what it is.
Yeah, but Memorial is very affordable.
I think there's some differential too, depending on if you're retired or some age. I don't know Memorial, so don't quote me on this, but I think there will be some differential depending on where you are in your life as well for things like that. So yeah, no, that's really interesting.
And I think people can audit if they don't need to do the exams, if they don't need to have the assignments graded, and if they don't need a grade, they can audit. And I think that's either free or cheap. Again, I don't know.
It's no fun to audit.
You need the
In
pressure.
for a penny, in for a pound.
I know when I did them, they were only $50, but that just
Yeah.
tells you how old I was.
They were a little more expensive for me, Gary, but still not that much. Yeah, that's true.
The whole semester was probably the cost of one class now.
Yeah, maybe.
I think actually Dave Newberry tried to do 2151 a couple years ago, and there were some issues with it. You know, actually needing to be admitted. So they aren't like extension courses. You actually have to be a memorial student to take them. So I'm not sure if these are different, but there may be a bit of an issue with that. So it might require some investigation.
Yeah, I'm working with that with Grenfell registrars. So again, that's my goal, to make them accessible. But right now it's in design stage.
Okay, thank you. Gary, do you want to do Chris next?
Yeah, let's do Chris.
So,
Okay.
and you're speaking about mini radio astronomy, is it?
Can people see my screen?
Yes.
Oh.
Yes, yes.
You are okay. Well, I'll start the show. So I got tired of well, two things. Of course, the very sad and unfortunate demise of the Arecibo Radio Observatory down Puerto Rico, August and November, and December, of course, sort of got everyone thinking about radio astronomy, and then the clouds came in and didn't seem to go. And I figured, so I reread Frank Drake's autobiography. I'm rereading Carl Sagan's Contact novel, and I decided, why not finish a project I started a little over a year ago, finally build a radio telescope, darn it, so I can see through the clouds. So, yeah, building a radio telescope doesn't mean necessarily a multi-million-dollar installation with a, football field-sized dish. In this case, it's a small plastic and metal thing that fits taped to the railing of your front deck. But it works. I see the Milky Way galaxy with this. So I've been, for a long, long time, I've been wanting to try radio astronomy. I will admit I'm a rank amateur at radio astronomy. Not so in optical perhaps, but rank amateur in radio. This all started when I was very young, and my father used to drive us out to the Pooch Cove satellite tracking station, the dish, and whoa, wow, a dish. It was the space age and yada yada. But the electronics were never there. It was all seemingly clunky and noisy. Fast forward several decades, more than I wish to admit, and the cell phones everywhere, microwave electronics are cheap and sensitive. And a little while ago, they came out with a company came up with a chip that would enable software to turn a dongle into USB dongle into a receiver, a very broad radio receiver. People are using these things for everything in radio, so, weather satellites, spying on aircraft, and so on. You can use it for radio astronomy too. So, the very, very quick, radio is just electromagnetic radiation like light or X-rays or anything. It's the longest wavelengths, very large, several decades of frequency of radio waves can get through the Earth's atmosphere as if it's not there. And actually, around the single-digit gigahertz frequencies, it cuts through the universe as if most of it's not there. The universe is very transparent to single-digit gigahertz radio waves, so you can see very far. Light gets through a narrow little window. Light has frequencies up in the hundreds of trillions of hertz. When atoms are made to jiggle that fast, they tend to block whatever's doing the jiggling. So gamma rays and X-rays don't get through the atmosphere. But radio is good. So you can see through the atmosphere in radio. Important if you're always clouded in. So what is a radio telescope? You need a photon collector, reflector, just the same as a telescope mirror, basically, to collect photons. But here the photons are radio photons. You focus them to a detector of some kind, which in my case is a wire, what's 1/4 wavelength long inside of a waveguide. You have a very, very sensitive low noise amplifier right there to amplify the signal and save it from noise before you're going to do anything else with it. So it's right there at the pickup. You have a filter to help the receivers filter and selecting what you want to look at. And of course, the receiver at the end. This is just a block diagram of a suggested radio setup for people who are interested in SETI, or the search for extraterrestrial intelligence. People like looking for aliens. And this is going in the 1990s, and a setup like this in the 1990s would cost you a lot of money, especially in the receiver and some of the electronics. So radio waves, like light, can be of any a source, a hot source. It emits radio waves in a continuous spectrum, just the same as it emits light in a continuous spectrum. And thin gas can also emit radio waves in emission lines. Very particular emission lines. A famous one is the neutral hydrogen line, famous one in radio astronomy. And that comes from a spin flip of the electron in neutral atoms. I don't want to get too much into the nitty gritty here, but if you're talking about H1, you need to know where it comes from. Every hydrogen atom, neutral hydrogen atom, has a bound electron, and the bound electron spin is either parallel or anti-parallel to the proton spin. As a unit, the net energy of the atom is lowest when the two spins are anti-parallel, and if they are parallel, the electron can flip its spin and shed that little bit of energy to relax the atom even further. The energy of the photon gives you a frequency of 1420.4058 megahertz, or a wavelength of 21 centimeters, and you'll hear astronomers talking about the 21 centimeter line over and over again. So we can build a radio telescope to look through rain clouds here on Earth and see hydrogen in the spiral arms of our own galaxy from the comfort of your own home, even when it's winter and raining. On this graphic, which I stole gratuitously from Wikipedia, there's a cartoon of the Milky Way and some spiral arms. With a setup like this, you're only going to be able to see the spiral arms near you. You need a monster dish to have the sensitivity to see the backside. We're here where the sun is. I'll try, but I'll show you what I've done. And to navigate, we define a coordinate system, galactic coordinates, where the plane of zero latitude is in the plane of the galaxy, and zero longitude is defined as looking towards Sagittarius, the center of the galaxy, and it increases 360 degrees going counterclockwise from above. Another important piece of the pie eventually is to recognize that spiral galaxies, and all galaxies really, and the planets in the disk of the solar system, do not rotate as a rigid disk. They rotate differentially. And this is important because this radio telescope of mine, or anyone's, when it looks at the Milky Way, you're not going to see just one sharp peak, one sharp line. If nothing was moving with respect to everything else, you'd see only one sharp line. But because we're 1/3 of the way out from the middle in the disk with other things that are in the disk, we'll see things moving towards us and away from us, depending on the line of sight, depending on the galactic longitude. So that can be used. So if you know the longitude you're looking at, you can look at the hydrogen profile and you can decode it into how far away the clouds are from you, and you can build a radio coordinate map of the Milky Way. Cool. At least I got the telescope built. I'll show you the rest of the numbers some other time. So, building the telescope. Two references I followed verbatim, really. One, I ran across a paper given at an American Astronomical Society poster session where a bunch of students at Harvard, under the direction of N. Patel, I forget what the N is, built a horn radio telescope, literally from cardboard with aluminum foil glued onto it, and they used a paint solvent can as the waveguide and a simple coax connector with a wire soldered into it. And the wire was 1/4 wavelength long, and it worked just fine. They used these an SDR, RTL SDR dongle, USB dongle, and micro and amplifiers, and they saw the galaxy, and they could measure various properties of the galaxy. The URL's on the bottom. I don't know if maybe you can look at that later from the recording of this talk. Incidentally, the 21 centimeter line was discovered in 1951 by Doc Ewan and Ed Purcell at Harvard using a horn telescope. There's a cover on this thing because, as you can well expect, when it rains, it fills up with water, and that's something you don't want. The other site I found is at the website of the bunch that sells that silver USB dongle receiver thing, and it hosts all kinds of stories. All kinds of people are doing things with the dongle. So here's the story: somebody used it to build a hydrogen radio telescope, and they used a grid parabolic dish used for Wi-Fi communications. The receiver wasn't even the dish wasn't even tuned to the right line. It was 2.4 gigahertz, not 1.4. But that's close enough to an order factor of 2, so they made it work. I just followed the directions to the letter. Free software called SDR Sharp, which is written sharp as in the musical symbol sharp, or written out SDRSHARP. All the software is free. The electronics are really cheap. Amazon.ca sells them, so for 55 bucks, you can buy the low noise amplifier, which has a hydrogen one line filter built into it. This thing is very sensitive. For another 55 bucks, you can buy the RTL silver dongle thing, the receiver. I bought a couple of USB extension cables. I had to buy a can of Thompson's water seal and pour the water seal into another container so I could use can. I paid $20 for the can. So here's what I did. I had a collection of small SMA connectors from previous attempts at radio astronomy. So I cut a small bit of copper, threaded it for some screws so I could attach it to the right part of the can, soldered on the connector. The connector is right angled, and so I wanted to get the electronics on the outside of the can not sticking out at a right angle. I wanted them flush the can, close to the metal, so no noise. That was a little bit of work with a propane torch and some solder. Afterwards, I took some brass capillary tubing and bent the end and soldered it over the pin. So it's a right angle down through here. And the part that sticks into the waveguide is 53 millimeters long. That is the probe that detects the radio waves focused by the horn. There's what the can emptied. Had a sticky plastic lining, which I grabbed some sticky ducting aluminum tape and lined the inside of the can with it. There's the probe stuck into the side. And this is mounted 67 millimeters up from the bottom. There are online calculators to work out exactly where you should put all this stuff. It's sort of like metal jewelry, geometry, statue making stuff. But here I just followed a recipe. To make the horn, plastic, a kind of plastic cardboard called Plasticor. You can buy the stuff at Kent. It's about $11 for a 2x4 foot sheet. I bought a couple, and some heavy duty aluminum foil and some spray adhesive. And then using the dimensions from the poster, cut out my pieces to make that horn. And here's the result. I stuck it all together with the HVAC tape again. This is the resulting horn. And on the bottom, you can see the waveguide with the electronics stuck to the outside of it with very gracefully with black tape. And a USD, so the signal comes from the probe right straight into the low noise amplifier, and then there's a little 6-inch pigtail which sends that signal back down into the receiver. So here the receiver is actually on the focus, if you will, of the telescope. And at this point, out of the back end of the receiver, it's just a digital signal, so it'll survive longer cable runs. I use a USB cable to run this into a laptop, into the living room window. You can see the cable here. I put a blue recycling bag taped over the aperture. Good thing too, because within an hour of setting this thing up, I went into work and it started pouring rain. And even though it was raining, when I came back, there was signal. I had to tape a white plastic bag over the electronics, of course, as well. I got a popular little green friend who helped me. A leftover from Christmas that was still in the living room. So the software, can people still hear me?
Yes.
Okay. The software running here is SDR Sharp, which is downloadable, and people use it for, again, for all kinds of things. There's a special plugin you download. The instructions are all there in that RTL site. The plugin takes a 5-minute integration. You have the antenna unplugged to take the first integration because that's a background. And then for all successive integration, it subtracts that 5-minute integration from all successive 5-minute integrations. So it's sort of a background subtracted thing. Software does this automatically. Next to this is just a stellarium window running, showing the sky at real time. Of course, the atmosphere turned off so you can see the night sky in the daytime. And just to show you what straight up is, the telescope's looking straight up. As the Earth rotates, the Milky Way rotates through the beam, with the child helping it all worked rather well. So here's where straight up is. It's actually very near Deneb, the star Deneb. The beam width for this telescope is about 25 degrees on the sky. It's not like an optical telescope where you see arc seconds or arc minutes. So it's an extremely fuzzy picture, if you will. But here are the hydrogen peaks, and multiple peaks, not just one, but they're Doppler shifted peaks, several. There are maybe 3 here, and each of the peaks is wide. So that's from Doppler shifting because the different clouds and the spiral arms are moving with respect to one another. So this is cool. This is actually better than I was expecting to get. Because look at the size of this, and it was working in the rain. And this is not expensive. I paid under $200 for this. Here's another profile. Again, the signal to noise is actually, I'm quite pleased with this. Also a neat check, I should have included one. At 3 or 4 in the morning this time of year, the Milky Way is definitely not overhead. The telescope is looking almost at right angles to the plane of the galaxy, and in fact, there's no signal here at all. This is just a flat line. These little tiny spikes are noise from electronics. If someone turns on the television or opens a laptop, an older laptop, yeah, watch out. So that's it. I meant to do the math and turn a bunch of these profiles into a bunch of points plotted on a radial coordinates to show you a map of the spiral arms, but I ran out of time, and my daughter needed to go get COVID testing and a bunch of other things. So that's it. It's something people can try.
Looking good, buddy. Looking good.
Any questions?
Any questions? Yes. I can stop sharing or
Stop sharing.
okay.
There's some stuff in the chat. Was any of that related to you?
Oh, I wasn't looking at the chat while I was.
I only see the number, so it's increasing. So
Oh,
Yeah, no,
okay.
a few comments in chat.
Oh, Phil says Song of Hydrogen. Mike says Purcell is my academic great grandfather. I met him in 1979. Oh, cool. Very cool, Mike. Is the probe about a quarter wavelength from the bottom of the can? A little more than that. Light travels at a different velocity inside a waveguide.
Oh, right.
So, yeah. And Jim says, can the software run on a Pi? Absolutely. A lot of people do this with Raspberry Pis. And the Kant astronomy model. Yes, Marcellus. So dirt cheap. And I just followed instructions from other websites. So if you are ever frustrated, you can look at at least you can look at the Galaxy's H1 while it's raining. Thanks.
thank you, Chris. Gary, do you want to do Nikolai next?
let's do Jim and people who put, and we'll see how it goes.
Okay, is Jim the only one you have
Okay.
for observations?
There's a few others.
There's actually nothing going on, so we can skip the WhatsApp if we're out of time.
Okay, can anybody hear me now?
Hi, Jim.
Hey, Jim.
Okay. Well, this is a continuation of what I've been doing from the last meeting when I showed some of the data that was that's being sold by the Royal Astronomical Society's Robotic Telescope project. Anyway, this is the I only have a couple of pictures here. This is the Cocoon Nebula, which is a stellar nursery, and this particular image was done in narrowband. This is my first attempt at processing narrowband data. So it's the H alpha, S2, and O3 lines. And this was processed in PixInsight and post-processed in Lightroom. There's some pixel math going on here to create what I called, or what is known as synthetic RGB from the narrowband data. And it turned out quite well with narrowband data, but I guess the only reason I put the equations on there was to basically mention that in addition to the H alpha, S2, and O3, these formulas basically synthesize the H beta line, which is the teal colored line that you see in nebulosity. This is 2,500 light years away in the constellation Cygnus, and the emission nebula is itself, in the H alpha is the ionized gas, and the blue reflection nebulosity is evident in this picture around as halos around the stars. So anyway, so that actually turned out a lot better. The color, even though we're looking at very narrow band, this synthesized as a fairly natural looking picture. So the next picture is our familiar Dumbbell Nebula. Again, this is with the robotic telescope, and this particular image was just basically a broadband LRGB, which is luminosity red, green, and blue. Typically, the RGB, the color channels, can be collected at the lower resolution than the luminosity channel, because we don't see detail in color. We see detail in black and white. So this type of data is a reflection of the LRGB data, which is a broadband data as opposed to the narrowband data. So we're expecting to get natural color here. Again, this was processed in PixInsight and Lightroom. The Dumbbell Nebula is a planetary nebula, which is a remnants from a supernova explosion in the constellation Vulpecula at a distance of, and this made me smile, 1,227 light years away. Any physicists on the here would kind of laugh at that level of accuracy and that number of significant digits. It's very anyway. The central star is now a white dwarf of roughly half a solar mass, and apparently the apparent kinematic age, the expansion of this cloud of nebulosity is such that we can calculate its age as roughly 9,800 years. So this particular image requires a lot more data in order to image the surrounding nebulosity, which is much fainter than this. Anyway, those are just what's been keeping me busy in the lack of any clear skies. But apparently this problem with the skies is global in nature. Everybody's complaining about this winter being one of the worst in many years.
So you'd recommend the RASC download?
You can you go online, you buy access to these data sets, and it's relatively inexpensive. If you're a student, it's even cheaper. I paid $100 for 30 data sets, and they just grant you access to the data. There's a stipulation that you put in a watermark, as you see, a credit to the Royal Astronomical Society of Canada's Robotic Telescope, which is, and then they want a copy of all the images that are processed with their data. So they're building up a little data set of images over at the RASC, and if you want to go out there, take a look and see what other people are doing. This is keeping me busy.
Thanks, Jim. Mike, you want to talk about your picture? Mike, are you there, Mike?
Okay, there.
Okay.
I might be there now.
Yes, you are. Mike took this on February the 7th at M33. He said it was cold and windy, and I think he's frozen up. So I'm gonna have to move on, again. Mike.
Also
nice.
on February 7th.
Yeah, it's a nice one actually. Pretty good.
Yeah.
I think it was taken with these 80 millimeter refractor. Okay. I put these in because I didn't have anybody showing up, and I don't do nice pictures like Jim and Mike. I do EAA, which is electronically aided astronomy. So I want to see things. My eyes are getting worse, so I just put this camera on and do. This is M42, 120 seconds. Shows some detail for me, but things like 1713, which is right here, and here, another one right there, a couple of galaxies. So I'm searching for galaxies that I haven't gotten able to see. And so this technique of using a video camera hooked up to my telescope and doing a few exposures, yeah, I can add on, but I just thought it'd be interesting. I just wanted to point that out. Okay. And I was cleaning up my sister's room, and she actually had a whole lot of pictures I took. This is Comet West, first comet I ever took pictures of in 1976. There it is, there and there. Quite impressive, actually. For that time, it was actually ASA 400 film. This is the solar eclipse in 79, the diamond ring I took. And we made, the RASC made front page of the Evening Telegram. There's Dr. Lockwood, Randy Dodge, Cheryl Furlong, now out in BC, Peter Olson, who's a member, and you, me. In different ways to look at the solar eclipse in 1979 when Randy and I went to Manitoba, Winnipeg, up to Lundar to see the solar eclipse. I thought that was kind of a nice flashback Thursday. And Chris, you want to go do this? I thought you'd have this in your slide thing, but you want to talk about it?
Oh my God, yeah, that, okay. Yeah, this thing is huge. I'm impressed that you got the animated GIF in. So I let the telescope run for 2 days while it was raining on and off, and when water would fill up in the plastic trough, I would boot it out because it would attenuate the signal. So I went through it and got a bunch of frames that were at least contiguous, more or less, and tried to put together an animated GIF showing through the course of the day, the sky scanning overhead and how the profile changes depending on the time of the sky. time of day you're looking. The thing to note is that right now, as the zenith is going through very close to the galactic North Pole, there's almost no signal. And then it comes back when you cross the galaxy, and you can see that the profile change shape and shift back and forth. And there's lots of information in there to decode and turn into a top-down view of the Milky Way. So that's basically it.
Okay. Thanks very much, guys, for sharing your pictures. Greatly appreciate it. Okay, Randy, I think we may have time for Nikolai. Nikolai wants to go ahead.
It's up to you. You tell me.
Go ahead. Yeah, go ahead, Nikolai.
All
I'll give you 10 minutes or until we get cut off, whichever comes first.
All right.
While he's doing that, while he's setting up, Chris, that was an excellent
Do you see
image of
this?
your thing. Yes,
Thank you.
can.
Okay. So let's see. All right. So sunrise and sunset times. Sun rising at 7 o'clock in the morning, setting 5:28. So day is getting bigger, and it will continue to do that. I'm sure you've noticed that. Rise and set times for the planets. Here's a picture of the sun from yesterday. It's completely blank, so it's back to that, low activity where it's been for a while, where it got punctuated by a couple of peaks, or not peaks, but moments of activity, but that's gone now. Planets. We have all night planets. Oh, this is a lie, actually. This should say evening planets, because those are definitely not visible all night right now. So in fact, they're only visible very early in the evening, Mars, Mercury, and Venus and Uranus. And all quite small and kind of difficult to observe. So it's not a great time for planetary observation right now. And Jupiter and Neptune, which recently became morning planets, are also visible very, very kind of late in the morning, just before sunrise. They just emerged from conjunctions with the sun. We have comets. The brightest one is Atlas, projected to peak at 6.3 in March. I looked for pictures, but I didn't see anything. It doesn't seem to be very popular. We have asteroids, we have supernovae, brightest one right now, I think magnitude 10. Meteor showers, nothing going on this time of year. Deep sky objects, those are the best place objects for February and March. ISS passes. And of course, observing sessions, which are not happening. But here is the observing calendars. This is February and this is March. So next meeting on March 17th. That's really it. Not much going on. But yeah, that should be it. Are there any questions?
Thanks, Nikolai.
Well, thanks very much.
No
Can
problem.
you unshare, please?
Yeah.
Thanks,
And,
Nikolai.
Thanks, Nikolai. Greatly appreciate you.
That report
Okay,
is
what
on the
else is
website.
What else is dear Randy?
I just wanted to mention tomorrow's a big Mars day. The Perseverance lander should be landing just before 5:30 tomorrow afternoon. I'm sure there'll be online stuff before that. I'm not sure about the schedule for the orbiter or the Chinese or the other one, the UAE, is it? So I'm sure if you go to YouTube, you'll be inundated by Mars coverage tomorrow.
Yeah, the other two went in last week. They went into orbit last week.
Yeah, I don't know when the lander is going to separate from one of the orbiters, though.
I think China's goes down in June.
Is it? Okay.
Yeah, several
Not-
months.
Yeah,
Okay.
not for a while.
Why are they waiting so long?
circularize their orbit or something.
Okay, could be. Yeah. The Americans have an orbiter as well, do they not?
Not with this mission. I think it's a
Okay.
one shot to surface.
Okay, I thought there was another orbiter as well.
They have a helicopter.
That's on this one, right? Yeah.
Yeah.
And apparently they'll be using the acoustic sensors on the landers to see if they can hear the landing.
That's right.
So
Marcellus has recognized those.
by the way, I wanted to mention that
After
all
you
of-
mentioned him last week, Chris.
yeah,
Yes. Now if it'll
All-
only clear so I can try it out.
all of our previous meetings since the pandemic are now on YouTube for you to enjoy.
Thanks, Randy.
Mhm.
Yes.
Yes, that was good work.
I've been twiddling with them the past few days. I've added subtitles and these sorts of things, but yeah, they're there. If anybody objects to anything they see on there with them, let me know. I can still do spot edits, as I'll be doing a lot of spot edits on this one. I usually take out gaps when, can you hear me now? You know, while people get set up for stuff. That's just a favor to everybody.
Much appreciated.
I think next month, Gary, we're talking about maybe a Mars review of what's currently on the go with Mars. Is that what we've mentioned, maybe?
I don't know. I've been out of
Yep.
touch with the
Yeah,
center. I've been.
Yep.
Yeah, I don't know if we set anything up for next month yet,
Okay.
but that sounds like a decent idea.
Okay. It's Lent now, so I guess we got to give up something, do we? What do we give up?
Clouds.
Oh no, we'll give up the darkness.
Give up clouds.
Yeah, right. That's gonna
Nice
work.
try.
Okay.
Well, that's all I have, Gary, on the agenda. I don't know if
Okay,
anybody else.
We've got about 5 minutes. If people want to take the mic off and chit chat, it'd be greatly appreciated to find out, get some feedback on what you want to do, what you want to see. Has anybody actually seen anything? How about you, James? Nobody wants to talk. That's
What about
odd.
Phil? He's not in cloudy Newfoundland.
No, I'm in cloudy southern Ontario. I haven't seen any stars for about 3 weeks now.
Well,
You're
okay.
getting some snow soon too, aren't you?
Yeah, we got about 30 centimeters there yesterday, and there's some more coming
Whoa.
tonight, I think.
Ooh, that's
That was
respectable.
this morning.
It's almost like local.
Yeah.
Yeah, not as windy.
Phil, you were talking
Straight out
about
of the sky. It's all very gentle and fluffy. It's all very nice. It's not at all like home.
Yeah, you should
you're
have been
saying
here shoveling our heavy sludge.
Yeah,
Very heavy.
No thanks.
been there, done that.
Yeah.
Actually,
remember,
Gary, you
tomorrow
mentioned that-
there's a talk. Tomorrow is
Svetlana's.
Svetlana's
Yeah.
talk.
yeah, and then on Saturday there's a meteor sky camera convention. Is that right, Phil?
Yeah, that's a fellow here by the name of Denny Veda, who is a postdoc now and in meteor physics, and he's organizing an online meeting of people who run meteor camera networks globally. Anybody around the world
Oh, wow.
can come in on that. And so it runs. I haven't seen anything more about this except his message today by email, which I forwarded to Gary. It's public. It's anybody can go to this. I guess we can circulate it around to the list, but basically, if you're interested in and wanted to find out what people are thinking about for meteor camera networks and some of the things, I think his purpose in this is trying to figure out how to standardize some of the observations and some of the techniques and maybe be able to pass tips back and forward. I don't know anything about it until I got the email today, so I'm all ears on that as well. But
Yes.
for anybody who's interested, yeah, you could just join in.
has, a
Gary's
lot of
got the
talk.
mail, and I'll send it around to the list, I guess, when we get off here.
I was going to say he's got a lot of speakers speaking too, so it'll be
Okay, good.
all over the world. So it'll be interesting to see how we communicate and what's going on in the world of shooting stars.
Yeah.
And Gary?
Yeah.
there was a something about a talk that I posted to the groups.io, but I'll maybe just mention it. It was last night or the night before. No, I guess just last night.
Yep.
By Samantha Lawler at Regina about trans-Neptunian objects and whether there is evidence for Planet 9 or not. It's very good. It's meant to be a talk for students, and you can see it on YouTube by just Googling Canadian Association of Physicists undergraduate lecture series, and the recording is there. I think Chris has had a look at it.
Yeah, I also replied to your email and posted the link, so it's there in the chat.
Oh, okay, good.
But be warned, the audio is a full half minute ahead of the video.
Well, it wasn't when I watched it.
Oh, okay.
So I watched it. I got back just as she was finishing, and the recording was there, so I just started playing it. And
You're ahead of your time anyway, Mike.
Whatever.
But it's a good talk.
Computer.
There was a note about the ninth planet on the BBC news site this afternoon.
I seen that, or actually, it was, I read on their webpage.
Yeah.
That was about her. That's about her work.
Okay. Yeah.
Okay. I'll go back and read it.
It was just an article in Science about her collaboration.
Yeah.
Search for Planet 9.
Yeah. Well, it turns out it's not there.
Yeah, it's a pretty neat idea. It's that the perturbations of the orbits that were thought
All the planets,
possibly the existence of an unknown gas giant planet or planet of some mass, chalking up to being a kind of observational bias. So, and that's what this is basically documenting.
I thought it was very convincing, actually, as well. The last quarter
Oh
of
my God. Hello, Doug.
Hey.
Hey, question for you.
Who else is out there?
Link for her presentation tomorrow. Is that posted somewhere?
It's in the chat window.
Yeah.
I don't see it.
It's in the chat, it's in the very beginning.
Yeah, it's way up top in the chat window.
Yeah. It's a WebEx link, of course, because it's mom.
Better get the link to that before we finish our Zoom, or it'll be gone.
Well, I think the one of us can dig it out of MON mail folders and put it on the talk IO as well.
You mean to Svetlana's talk?
Yeah.
Yes.
So it'll either be Mike or you, right, Chris? Right,
Well,
Chris?
I believe I saw this advertised on one email, so.
Okay, put it on the list first so that other people can see it.
Yep,
Even though
I'll do that
members
right
who
after
haven't
the
been
meeting.
here.
Yep.
Yeah, greatly appreciate it. Thank you.
Okay.
Anyway, we're going to have to go, guys. I
Okay.
want to
Yes.
thank you very much for the meeting. Any last minute questions, answers?
Okay.
All right. Good night.
Cheers.
Good observing.
Good night, everybody.
Hope you
Good
get
night.
clear
See you all
skies.
Good to
I'll
see
see you
everybody.
tomorrow.
Thanks a
all.
lot.
Thanks, all
See you tomorrow.
speakers.
Bye.
Bye.